6 minutes ago, humanity's second most distant spacecraft transmitted something back to Earth that shouldn't technically exist. A sound. Not silence, not static, not empty nothingness, but an actual, structured, continuous tone arriving from a region of space scientists were taught for generations was a perfect silent vacuum. Voyager 2 is out there, right now, quietly picking up a sound the human ear was never supposed to hear, and what it reveals about interstellar space is genuinely reshaping how scientists think about what actually fills the emptiness between the stars. Stick around, because this isn't science fiction, and it isn't an exaggeration for a headline. This is real data, transmitted across billions of miles, and it's forcing scientists to rethink something most of us learned as an absolute rule of the universe. Let's start with what most of us grew up believing about sound in space. In space, no one can hear you scream. It's practically a law of physics recited in nearly every science fiction movie ever made, and for good reason. Sound waves, the kind we hear every day here on Earth, need a medium to travel through. Air, water, some kind of physical substance whose particles can bump into each other and carry vibration outward. Space is, by definition, mostly empty. No air, no medium, no way for traditional sound waves to travel at all. In that sense, the old saying holds up perfectly. But Voyager 2 carries an instrument that measures something slightly different, and that difference changes everything. It's called the plasma wave subsystem, and instead of listening for sound in the traditional sense, it detects vibrations in plasma, the electrically charged gas that actually does exist, thinly scattered, throughout the space between stars. Even in the emptiest stretches of the galaxy, tiny numbers of charged particles drift through the darkness, and when disturbed, those particles ripple and oscillate in patterns that can be measured electronically, then translated into frequencies the human ear can actually process. If you're new to this channel, we cover discoveries exactly like this one every single week, so make sure you're subscribed before we continue. Because what Voyager's instruments have been quietly recording out there is honestly one of the strangest things to come out of the entire mission. Here's where the story gets genuinely eerie. When scientists first began analyzing this plasma wave data from the Voyager spacecraft, after they crossed into interstellar space, they expected occasional bursts of activity, brief spikes triggered by specific events, like a coronal mass ejection from the sun sending a shockwave rippling outward through space. What they found instead was something nobody had fully anticipated. A persistent, continuous hum, not a burst, not an occasional spike, a steady, ongoing tone present in the data almost constantly, as if the empty space between the stars was quietly vibrating all on its own, all the time, whether or not any dramatic solar event had triggered it. Researchers described this discovery in genuinely poetic terms. One team, studying the phenomenon, noted that this continuous emission meant interstellar space wasn't silent after all, that it was, in a real sense, alive with faint, constant activity, humming quietly in the background of the galaxy, far beyond anything scientists had previously measured directly. It wasn't the kind of dramatic, alarming sound you might picture from a science fiction trailer. It was something closer to a low, steady drone, structured and consistent rather than random noise, as if some faint signal was reverberating endlessly through the emptiness surrounding the spacecraft. If a genuinely real recording of the sound of interstellar space is the kind of thing that fascinates you as much as it fascinates me, do me a quick favor and hit that like button. It genuinely helps this channel keep making videos exactly like this one. What makes this hum scientifically valuable goes far beyond simply being an eerie curiosity. The pitch and frequency of these plasma vibrations directly tell researchers something concrete and measurable, the density of the ionized gas surrounding the spacecraft at that exact moment. Inside the protective bubble of our sun's heliosphere, these tones registered relatively low, roughly around 300 Hz, consistent with the thin, rarefied solar wind found close to home. Once the spacecraft crossed fully into interstellar space, the pitch jumped noticeably higher, climbing into a range between 2 and 3 kHz, a direct signal that the plasma out there is significantly denser than the plasma found inside our own solar system's bubble. That single detail, the frequency shift itself, became one of the most important pieces of evidence scientists used to confirm exactly when each Voyager spacecraft had truly left the heliosphere and entered interstellar space for good. It wasn't a guess. It wasn't an indirect calculation. It was, quite literally, the changing pitch of the surrounding environment, captured directly by an instrument riding along on the spacecraft itself, translated into a tone scientists could actually sit down and listen to. For years, this hum was thought to require a trigger, specifically a large solar eruption sending a shockwave rippling outward through the solar system, eventually compressing the surrounding plasma enough to generate a detectable vibration as it passed. Under that assumption, researchers expected these tones to appear only occasionally, brief windows following major solar events, then fade back into silence once that shockwave's energy dissipated. Instead, continued monitoring revealed something scientists hadn't planned for. The hum wasn't fading away between events. It was persisting, quietly, almost continuously, suggesting interstellar space carries a genuine, ongoing low level of activity that exists independently of any single dramatic trigger from the sun. That persistent nature completely reshaped how scientists think about the environment surrounding both Voyager spacecraft. Rather than picturing empty, silent space punctuated by the occasional dramatic disturbance, researchers now understand interstellar space as a genuinely dynamic environment, quietly active essentially all the time, filled with faint, ongoing vibrations rippling through its thin scattering of charged particles, whether or not any major solar event happens to be occurring at that particular moment. This shift in understanding matters for reasons that extend well beyond simple curiosity. The density and behavior of interstellar plasma directly affects our understanding of the overall shape and structure of the heliosphere, the protective magnetic bubble surrounding our entire solar system. It even connects to bigger questions about how stars form and how galaxies like our own evolve over enormous stretches of cosmic time. Every additional data point captured by Voyager's aging plasma wave instrument adds another small piece toward answering questions that stretch far beyond just our own solar system's immediate neighborhood. There's something remarkable, almost humbling, about the fact that this discovery came from hardware, built using 1970s engineering, technology that predates almost every device most of us use today by nearly half a century. The plasma wave subsystem relies on a pair of long antennas extending outward from the spacecraft, originally designed to detect electromagnetic disturbances in the solar wind close to home. Never specifically engineered with the expectation that they'd still be capturing meaningful data from interstellar space, decades after launch, from a region of the galaxy nobody had ever directly measured before. And yet, here we are, with both Voyager spacecraft continuing to send back this strange, structured hum, a sound scientists can play through a speaker and genuinely listen to, even though no human ear, floating unprotected in that same region of space, could ever actually hear it directly. It exists purely as data, converted carefully into frequencies our biology happens to recognize as sound, a translation bridging the gap between raw electromagnetic measurement and something a human mind can intuitively process and feel. Every year, this discovery becomes more valuable, precisely because there is currently no other way to obtain it. No other spacecraft has ever operated this far from the sun, this deep into interstellar space, for this long. Nothing currently under construction will reach this same region for decades to come. That leaves Voyager 2 and its aging twin as humanity's only living witnesses to whatever quiet, persistent hum genuinely fills the space between our star and the next one over, a signal we would have no way of ever detecting on our own without a spacecraft physically present out there listening. There's an important scientific distinction buried inside this story that's worth taking a moment to fully understand, because it's part of what makes the discovery so credible rather than just a dramatic headline. The plasma wave subsystem, strictly speaking, does not detect sound in the traditional physical sense. It measures oscillations in electrons within the surrounding plasma, tiny fluctuations in an electric field that occur at frequencies happening to fall within the range of human hearing, roughly between a few hundred and a few thousand hertz. Scientists working on the instrument have been careful to clarify this distinction publicly, explaining that what listeners are actually hearing when this data gets played through a speaker is a faithful audio translation of real electromagnetic activity, not literal sound waves traveling through a vacuum. That clarification doesn't make the discovery any less remarkable. If anything, it makes it more impressive, because it means an instrument built decades before anyone understood exactly what it might eventually detect is now allowing humans to perceive, through their own ears, activity happening in an environment fundamentally hostile to the very concept of sound as we normally understand it. This kind of translation between different types of data happens more often in astronomy than most people realize, and it's part of why space agencies increasingly release these kinds of recordings to the public. Raw numbers on a graph rarely capture the imagination the way an actual audible tone can. When people hear that low, structured hum for themselves, played through their own speakers or headphones, it creates an immediate, visceral connection to a place that would otherwise remain an abstract concept, numbers scrolling across a screen in a research lab. That emotional resonance is part of why this particular Voyager discovery captured public attention so strongly when it was first announced, spreading well beyond typical scientific circles into mainstream news coverage and casual conversation. It's also worth remembering just how differently interstellar space behaves compared to the environment closer to home that most of us intuitively picture when we imagine outer space. Near Earth, and even throughout much of our own solar system, the solar wind constantly pushes outward from the sun, creating a relatively predictable, well-studied environment that spacecraft Engineers have decades of experience navigating. Interstellar space operates under an entirely different set of physical conditions, shaped instead by the ancient remnants of long-dead stars, plasma released by stellar explosions that occurred millions of years before humans ever existed, drifting slowly through the galaxy ever since. Every recording Voyager 2 sends back from this region offers scientists a genuinely rare glimpse into an environment shaped by cosmic history far older than our own solar system itself. There's also a quieter, more personal layer to this story that's easy to overlook amid all the technical detail. Voyager 2 was never originally designed to spend decades operating this far from home, listening to an environment nobody had ever directly sampled before. Its plasma wave instrument was built to study the solar wind and the outer planets during a mission expected to last only a handful of years. The fact that this same piece of hardware is still functioning well enough, nearly 5 decades later, to capture something as subtle and delicate as a persistent interstellar hum, says something remarkable about the engineering choices made by a small team of scientists and technicians working in the 1970s, most of whom likely never imagined their instrument would still be transmitting usable data from beyond the edge of the solar system into the second half of the 21st century's opening decades. That kind of unexpected longevity carries real scientific weight too, because Voyager 2's plasma wave instrument has now been recording data continuously across such an enormous span of time. Researchers can study not just individual moments of activity, but long-term patterns and trends in how interstellar plasma density and behavior might slowly shift as the spacecraft continues drifting farther and farther from our sun. No shorter mission, however sophisticated, could ever hope to capture the kind of extended timeline Voyager 2 has quietly built up simply by continuing to survive and keep transmitting, year after year, decade after decade. Long after its original mission, planners assumed the spacecraft would have gone silent. Scientists studying this ongoing hum are continuing to refine their understanding of exactly what triggers its persistence and whether its intensity and frequency shift meaningfully over longer stretches of time as Voyager 2 continues its outward journey. Each new batch of data adds another small thread to a much larger picture, one astronomers are still actively piecing together, using an instrument nobody ever expected to still be useful this far into the mission's improbably long life. If interstellar space really is quietly humming all the time, constantly vibrating in ways nobody expected before these spacecraft actually arrived to listen, what else might be happening out there in the vast, seemingly empty stretches of the galaxy that we simply have no instruments capable of detecting yet? Drop your thoughts in the comments and let me know what you think that constant hum is really telling us about the space between the stars. If this story pulled you in the way it pulled me in while researching it, hit that like button. It genuinely helps this channel keep telling stories like this one. And subscribe if you haven't already, because Voyager 2 is still out there, still listening, and still sending back sounds nobody expected to hear. Somewhere past the edge of our solar system right now, a 49-year-old spacecraft is quietly recording a hum that was never supposed to exist, proof that even in the emptiest reaches of the galaxy, space still has something to say, still humming quietly for anyone patient enough and far enough away to actually listen.